My name is Liam Weston and welcome to Physics Through Gaming. Fortnite is one of the most popular games today and offers players a unique chance to prove their skills in a cartoony battle royale. The players must use whatever they can to be the last person standing as a dangerous storm encircles them. One of these items players can use is a pack of balloons. This obviously isn't how it works in real life, but what about in Fortnite? What's different? Today we're going to investigate the physics of Fortnite and learn about the nature of buoyancy. So the first things we need to do is find a few things about the world of Fortnite as it's shown in the game. The first thing we will need to know is how fast these balloons accelerate into the air, and we need to find out the gravity of the world. To find the gravitational force of a planet is actually quite easy. We just need a crash test dummy, as you can see here, and we need him to fall off a giant tower, and then we're going to measure how long he takes to fall. I have created this tower, and we're going to fling our favorite dummy straight off of it. We're going to have him jump from several different heights, so we can gather enough data that we can find the acceleration of the planet. There's actually a simple kinematic equation that we're going to use. X equals v times t plus 1/2 at squared. Each of these things represent different part of the data we're going to collect. X represents any distance, and so in our scenario, this is going to be the height of our tower. V is our starting velocity, and since we have none of that, that's going to equal 0 and not contribute to our equation. Then we have 1/2 at squared. A is our acceleration. This will allow us to find the acceleration of gravity for this planet, and then t is obviously time. You may be wondering, how do we find the height of our tower? Well, luckily, the game already can tell us this. Each time we jump, we'll be able to find out exactly how far we fall. This will also enable us to determine relative sizes in real life because the distance is measured in meters. On the first fall, the dummy fell a height of 111 meters in 3.18 seconds. Then we did this again, and we found that he fell in 3.2 seconds. This gives an average acceleration of around 21.9 meters per second squared. This is a huge gravitational force and really makes you rethink the world of Fortnite and how you'd expect things to work. So we need to find out how long it takes our player to go from the bottom to the top of the tower. We're going to do this twice so we have a nice average, and it will eliminate some of just human error. So we do it twice, and we have found that the first one took 12.21 seconds, and the second took 12.01 seconds. Now we can plug those numbers back into our equation, and we find that the average acceleration upward is 1.512 meters per second squared. So now let's talk about buoyancy. Buoyancy is a tendency of objects of different densities to float or sink in a fluid that is either higher or lower density. This is why wood floats in water because it's less dense, and why a rock that is more dense will sink. This also applies to gases, and more importantly can describe why helium floats in air. The density of helium is much less than the air, so the buoyancy force of helium is going to be fairly large. Let's look into the equations you're going to need to calculate buoyancy, and look at how objects move to begin with. Newton told us that objects don't change how they move on their own, and there must be some force acting on it to change that. Objects accelerate when there's an imbalance of forces, so let's draw a little picture. We'll simplify this as much as possible, but essentially we just have a balloon, a person, and the gravity acting on the person in the balloon, and the buoyancy force that's going to be pulling us up. The buoyancy force is equal to the density of the air that the object's in, times the volume that it's taken up, so in this case our balloons, and the acceleration of the planet. So we can actually rewrite this as the buoyancy force minus our total mass times gravity equals our net force. Since we know our force is mass times acceleration, so our net force is going to be our total mass times the acceleration we found earlier, which is 1.52 meters per second squared. So let's list what our total mass is. It's the mass of the person, plus the balloons, plus the mass of the helium. There are still two things we don't know about our equation that we need to find in order to unlock the true nature of buoyancy. We need to find the volume taken up by the balloons, and we need to find the density of the air. Let's start with the balloons. Since we know how big a meter is in Fortnite, we can estimate these sizes. The tower was 111 meters tall, and we also know that it's 29 blocks tall, so each block is 3.8 meters tall. And based on some pixel measurements, I estimated the balloons have a radius of 0.1667 meters. This can not only help us find the volume that we're looking for, but also the mass of the helium and the mass of the balloons themselves. We know the density of helium, so we can rearrange our equation and find the mass. And so when I did that, I found that there was 0.019 kilograms per balloon, and each balloon weighs 3.5 grams. So now we're ready to find the density of the air in Fortnite. We have our buoyancy force, which is 0.097, which is the volume of the balloons times 5, because we have 5 balloons, times the gravity, times the density. Then we need to find our total mass. Using an average person around 70 kilograms, I find our total mass is to be about 70.035 kilograms, times our gravity, which is 21.9 again, equals our total mass again, times the acceleration upwards that we found over a balloon, and which is 1.52 meters per second squared. Solving for density, we found that the density of the air must be around 770 kilograms per meters cubed. This is insane. For comparison, the atmosphere of Earth has a density of 1.29 kilograms per meter cubed, and the density of Saturn is only 687. This is more dense than Saturn. What this shows us is that balloons' behavior is highly dependent on the density of the fluid the object's in. And to add a little fun note at the end of this video, I went ahead and calculated the number of balloons we'd actually need to float on Earth, and I found there was over 4,000 balloons. Fortnite is a very fun game, and I believe using this as a method of teaching can offer a unique way to demonstrate physics and the world around us. Thank you, this has been Liam Weston, and I hope you enjoyed my video.